Now, in third lesson, practice set 13, we are going to learn to find out the LCM of the given numbers. LCM is, as I have told you earlier, it's the least common multiple of the numbers. The methods which we are going to use is the vertical method. Okay. For HCF also, we have seen both the methods, horizontal method and vertical method. But vertical method is more convenient. I will show this one sum with both the methods. Whichever you follow convenient, that you can use. But for rest of the sums, I will use the vertical method. So first sum is 12 and 15. Two numbers they have given is 12 and 15, and we have to find out the LCM for these numbers. So as usual, we know in vertical method we have to draw lines, correct? So one first number here, second number here you have to write, and one horizontal line. Now you have to find out or start counting in from 1 onwards. Okay, you have to start with the number 2. Now if you see the number 2, you have to divide by 12. So 2 6 are 12. But 15 doesn't come in the table of 2. Correct? So we can't take 2. I have to find out the factor, prime factor, by which you can divide both the numbers. So after 2 comes 3. Let us try with 3. If you divide 12 by 3, 3 4s are 12. Can you divide 15 by 3? Yes. So 3 5s are 15. So I can use number 3. So I will write here first factor as a 3. Divide 12 by 3, it will come over here 4. 3 4s are 12 and 3 5s are 15. Now once you found these numbers, you have to further factorize these numbers, correct? But if you see out of these two numbers, 4 you can divide by 2, but 5 is the number. This is a prime number, means it doesn't have any other factor than 1 and 5. So we cannot proceed further. We have to stop here, correct? Now in HCF, while finding HCF, what we did, HCF must be 3. Okay, so FCF for these number will be 3. But now we don't have to find HCF. We have to find the LCM. Now what is the method to find the LCM? Correct? What we have to do here, LCM is equal to, we have to write this first factor which is over here, correct? That is HCF. And the downside two prime numbers, last one, okay? Wherever you further can't do the division, there we have to stop. So I have to take here 4 and then 5. Okay, so 3, 4, 5. And we have to multiply it. So what will come here? 3 4s are 12. And 12 into 5 will be 60. 12 5s are 60. So final answer what we get over here? That is 360. 60. Okay. Now this is about vertical method. One example I will show you for the horizontal method as well. Okay, whichever you find convenient you can do, correct? So you have to write down the factors for 2. What will be the factors for 2? 2 into 3, that is 2 2s are 4, 4 3s are 12. So these are the factors for 12. And what are the factors for 15? 3 into 5. Correct? Now here only 2 numbers are there. Whenever 3 numbers are being given, we have to write the factors for all 3 numbers. Now while finding out the LCM, we have to find out the common number between these 2. Correct? Which is the common number? That is 3. So 3 will be its HCF. So LCM is equal to that 3. One time you have to write, and then write the remaining numbers, that is 2 into 2 into 5, and that you have to multiply. 3 2s are 6, 6 2s are 12, 12 5s are 16. Correct? So this is the horizontal method. And here first one which we have found, that is a vertical method. But what happen, no, whenever three numbers will be given to you, it becomes confusing. Okay, sometime it is common in two, then we have to take it one time. Then wherever it is only two time common, three times common, so that is little bit confusing. So I am not proceeding with this method for further this practice set 13. We will be using first method. Now, in second sum, we'll write the three numbers 6, 8, 10. Okay. First number, we will try with 2. Correct? 2 3s are 6, 2 4s are 8 and 2 5s are 10. Now, out of these three numbers, 3, 4 and 5, you can see that 3 and 5 are the prime numbers. Prime numbers means we cannot further find out the factors. 3 ones are 3 and 5 ones are 5. Correct? So, we have to stop here. So, what will be the LCM? Our LCM is equal to, first you have to write this factor 2, then these 3, that is 3, 4 and 5. 3 into 4 into 5 is equal to, you have to multiply the number. 2 3s are 6, 6 4s are 24, correct, and 24 5s are 120. So 120 will be the LCM for second sum. Okay, let's see for third one. Okay, sorry, 18 and 32. So start dividing it by 2. You can divide 18 and 32 by 2. So 18 divided by 2, 2 9s are 18 and 16 2s are 32. Correct? Here 9 and 16. If you want to find out the factor, same number by which you can divide this, you can't, because one is odd number, other is even number. So you can't find any single factor by which you can divide 9 and 16. So we have to stop here and you have to write answer, that is LCM is equal to 2 multiplied by 9 multiplied by 16. And if you do the multiplication, you will get the answer 288. Correct? Some of the answers previously I have solved, so that in video while explanation we should not waste our time. Okay. Now let's go for fourth one. 10, 15 and 20. First of all, start with the number 2. Now some of you might ask, teacher, can we start directly by 3, directly by 5? Don't do it that way. Always you should start with the prime number from the smaller one. Okay. 2 5s are 10. 15 we cannot divide, so you have to write it as it is. See, this is very important step, children. Here I am dividing this by 2. So 10 I divided, I wrote here 5. Now 15 doesn't come in the table of 2. So you have to write 15 as it is down. And 2 10s are 20. Correct? Here. Now you cannot or you can continue with the number 5. That by 5 you can divide all the numbers. Correct? So 5 1s are 5. 5 3s are 15. 5 2s are 10. So 1, 3 and 2, these are all, I will shift it little bit up. Okay. So 1, 3 and 2, these are prime numbers. So we cannot proceed further. We have to stop. Now one explanation I want to give here. Some children will ask, teacher, can we write 2 here? Because 10 ko you can divide by 2. Yes. If you write here 2, so 5 will be as it is. 15 will be as it is, and here it will come 5. So one more step will be added. There you will write here 5 and divide all the fact numbers. So it is up to you. You can take 5, you can take 2. It is okay. Now write down the LCM. LCM is equal to 2 into 5 into 1 into 3 into 2. In short, we have to write all the factors, this side and down side. So what is the number? 2 5s are 10, 10 1s are 10, 10 3s are 30, 32s are 60. So this will be the answer for fourth one. Let's see the fifth one. Now fifth one number or fifth sum, if you see, they are co-prime numbers 45 and 86. Means there is not a single number by which you can divide the both numbers. So we'll write here 45 and 86 are co-prime. Means we cannot find out the factors for this. So directly how we have to do then? LCM is equal to 45 into 86. You have to do this in rough work. 45 into 86, 3870. So this will be the answer. Why we wrote for this one? Because these are the co-prime numbers, means we cannot find any single factor for 45 and 86 which can divide both. So we have written 45 and 86 are co-prime numbers, and therefore LCM, for finding LCM what we have to do? We have to directly multiply both the numbers. Now sixth sum in practice set 13, three numbers 15, 30 and 90. So we'll write them 15, 30 and 90. First number that we are going to start with the trial and error method, that is 2. Correct? You know that 15 doesn't come in the table of 2. So you cannot divide 15 by 2. So 15 we will write as it is. Okay. Then 30 you can divide it by 2. Right? So 15 2s are 30. And 45 2s are 90. Now these I am doing it orally, children. If you can't, you can just do the division in the rough work. Correct? So next, if you see 15, 15 and 45. So here we can't use 2 because all numbers are odd numbers. So I will start with 3. Divide 15 by 3. What you will get? 3 5s are 15. Here also 3 5s are 15. And 15 3s are 45. Okay. You have to divide 45 by 3. You will get 15 as a quotient. Then 5. Correct. 5 1s are 5. 5 1s are 5. And 5 3s are 15. Or else how you can do? Here you can write 3. So 5 will be as it is. 5 will be as it is. And here it will come 5. Correct. So one more number will be coming over here, that is 5. So and that way also will do. This way also is a correct one. Okay. Now after this 1 1 3. So we have to stop because one number is neither prime nor composite. You cannot find further factors. So we'll write LCM is equal to, first write this side number, that is 2 into 3 into 5 into 1. Now 1 no need to write. Even if you write it's okay. 1 into 3. Correct? Do the multiplication. 2 3s are 6. 6 5s are 30. 31s are 30. Okay, and 33s are 90. So answer what we get is 90. LCM for these three number is 90. Now let's start with 105 and 195. Okay, start with trial with the 2 number, but you know that both the numbers are odd numbers, so we can't use 2 over here. So we start with 3. 3 3s are 9. 3 5s are 15. 3 6s are 18. 3 5s are 15. See how I am dividing? I am dividing it orally over here. And you also practice in the same way, because every time you cannot go backside and do the rough work. It will take a time. So now in first initial sums it's okay. But now you should practice orally to divide it. Okay. Now if you see, you cannot divide it by 3 further, because 35 doesn't come in the table of 3. 65 also doesn't come in the table of 3. So we have to try with the 5. 35, correct? 35 divided by 5. 5 sevens are 35. 5 ones are 5, 5 threes are 15. Correct? So, here, what you get now here? LCM 7 and 13 both are prime numbers. So, we have to stop and we have to write answer. LCM is equal to 3 into 5 into 7 into 13. Do the multiplication in rough, will get the number 1365. So this will be the LCM for 105 and 195. Correct? This I am not doing, this is simple multiplication. You have to do it in a rough work. Okay? Because we don't have that much time that every rough step I can show it to you. If you have doubts, you can call me or you can WhatsApp your doubts. Okay? Next. 8th one, 12, 15 and 45. Start with 2. 2 6 are 12 and 15 you can't do divide by 2. So 15 as it is. 45 also you can't divide, so 45 as it is. Again continue with 2. 2 3s are 6. 15 will be as it is. 45 will be as it is. Now start with 3. 3 ones are 3, 3 5s are 15 and 15 threes are 45. Okay, then 5. 1 will be as it is. 5 ones are 5, 5 threes are 15. So, I get number here 1 1 3 and 2 2 3 5. Correct? So, we have to write down the LCM. Okay, now I am writing on this side, or little bit I will shift it up so that you can see it properly. LCM for 8th one is equal to 2 into 2 into 3 into 5 into, directly I am writing these 3, 1 I am not writing because 1 will not have any value in this multiplication. 2 2s are 4, 4 3s are 12, 12 5s are 60 and 63s are 180. Okay, so this is LCM for 12, 15 and 45. So here I have solved 3 sums, correct? Now 9th sum is 63 and 81. So first column will write 63, second column 81. Okay, so in if you do the addition of these two numbers 6 and 3, 8 plus 1, both it comes 9. That means as per the test of divisibility by 3, we can conclude that both will be divisible by 3. If you don't remember the test for divisibility, directly you try with 2 first. If you can't, then go for 3. Correct? So 3 I will write here. 3 2s are 6, 3 1s are 3. And here 3 2s are 6, 3 7s are 21. Okay. Then again divided by 3, 3 7s are 21, 3 9s are 27. Okay. Then one number 3 I will write here. You cannot divide 7 by 3. So 7 will be as it is and 3 3s are 9. So which numbers will come over here? Now both the numbers are prime numbers. So we have to stop and write the LCM is equal to 3 into 3 into 3 and 7 into 3. So I will write here 3 into 3 into 3 into 7 into 3 is equal to. Correct? You have to do the multiplication. 3 3s are 9, 9 3s are 27, 27 7s 189 and 189 into 3 it will come 567. So this will be the LCM. See, this answer you can't find it orally. I have already calculated it in a rough work and found the answer. Okay, so you also do the same work. If the numbers are bigger, if the numbers are greater, you have to do the rough work compulsorily. Even if you can do it with the oral, but to confirm the answers, do it in a rough work. Now next last one, for question number 1 is 18, 36 and 27. Start it with 2. 2 nines are 18, 2 18s are 18 twos are 36 and 27 will be as it is. Then 2 can't divide 9 by 2, so 9 will be as it is. 2 nines are 18, 27 will be as it is. Now go for 3. Correct? 3 threes are 9, 3 threes are 9, 3 nines are 27. Again 3, 3 ones are 3, 3 ones are 3 and 3 threes are 9. So once we get the prime numbers at both the side, we have to write down the factors. That is 2 into 2 into 3 into 3 and into 3. This one I am not writing. Even if you write, it's okay. Okay. Do the multiplication. 2 twos are 4. 4 threes are 12. 12 threes are 36. 36 threes are 108. So this will be the LCM for last sum. In practice set 13, question number 2 is find the HCF and LCM of the numbers given below. Verify that their product is equal to the product of the given numbers. Means till now we have found individually LCM and HCF. Here we have to find both HCF and LCM together, and after that we have to verify. Verify means we have to check that their product is equal to the product of the given numbers. Their product means whose? HCF and LCM. Its multiplication should be equal to the multiplication of the given numbers. Okay, so first of all, let us find out the HCF and LCM for the given numbers. Okay, so let us start here. 32 and 37 is the first number, but as 32 and 37, if you look at both the numbers, these are the co-prime numbers. Okay, means we don't have any other factor than 1 in between these two. So we can write here 32 and 37 are co-prime numbers. Therefore, HCF for 32 and 37 is equal to 1. We have to continue to find out the LCM. For LCM calculation, we'll draw one vertical, horizontal lines, correct? And then we will proceed. So, in first column write down 32, second column write down 37. Start dividing number by 2. 2 16s are 32. 37 you cannot divide by 2. So you have to write as it is. Then 2 8s are 16. So 2 here, 2 8s are 16. 8. And 37 again as it is. Again 2 4s are 8. So you will write here 4 and here will be 37. 2 2s are 4. So here 2 and here 37. Again 2 1s are 2 and 37 as it is. Now once you have reached two prime numbers down, that is 1 and 37. Correct? We don't have to proceed further. We have to stop at this place. Correct? So we have to write down the LCM. LCM means what? Multiplication of these side factor and downside factors. We have to write them together. So LCM is equal to 2 into 2 into 5 times there. So I will write it 5 times into 1 into 37. Correct? So this number, if you calculate for 5 times, it will come 32 into 37 and number comes how much? 1184. I have already calculated it. So I got this number, that is 1184. Now we have found the HCF. We have found the LCM. What is our question? we have to verify that their product is equal to the product of the given numbers. So, product of the given numbers means these two numbers. Its product should be equal to HCF into LCM. So, we will write it down. How we can write down that product of two numbers or given numbers is equal to HCF into LCM. Okay, so product of two numbers 32 into 37 is equal to 1184. Same, if you now this is same 32 and 37. So how about we can write 1184 is equal to 1184. Means we have proved or we have seen the property that product of any two number is always equal to the product of HCF and LCM. So this is how we have to find out the product of two numbers, and this way we have to solve this. Okay, now let's see for the second sum. Now in second sum, if you see the number 46 and 51, two numbers are given, and again we can say that both are the numbers which don't have any common prime factors. Means this is odd number, this is even number. So you cannot divide or you don't have any common number over here. Okay, so same way we have to write that 46 and 51 have no common prime factors. No common prime factors. Okay, so HCF for this number, okay, there only one is the common number. So HCF is equal to 1. To find out the common number or LCM, we will do the second method, that is drawing vertical lines and finding out the factors. So we'll write down first column 46 and this is 51. First I will start division by 2. 2 2s are 4, 2 3s are 6, 51 as it is. Now here 23. Now 23 is a prime number. You don't have any other number which can divide 23. So I will write here 23 ones are 23 and here 51 will be as it is. Now here I can write down the factors for 51, that is 3, and I can write 17 3s are 51. 1 will be as it is. Now you can see we cannot find out the further prime factors. So we have to stop here. Okay. So LCM, how we will write LCM then? LCM is equal to these factors and this factor. So 2 into 23 into 3 into 1 into 17. Okay. So total or this multiplication, what will be the multiplication? Okay, if you do this multiplication in rough work, you will get the number 2346. Correct? So this is LCM. Now we have to find out the product of LCM, HCF and LCM. That is HCF into LCM is equal to 1 into 2346. That is same, it will be 2346. Now product of two numbers. Which are the two number? Product of numbers is equal to 46 into 51. And if you do that multiplication, you get the same number, that is 2346. Therefore, we can write HCF into LCM is equal to product of numbers. That is 2346 is equal to 2346. This is this is true. Okay, so this is how you have to solve this sum. Let us now third sum in practice set 13. Two numbers given are 15 and 60. So we have to find out the HCF and LCM for this. Now to find out the HCM, we have to search for the number or prime number by which you can divide 15 and 60 at a time. Okay, so first number, if you check for 2, you can divide 60 by 2, but you can't divide the 15. So we can't take 2 here, we will take 3. Correct. So here will come 3 5s are 15 and 3 20 or 23s are 60. Next again we'll take 5, 5 1s are 5, 5 4s are 20. Now 1 and 4, the numbers came in such a way that there is no other number common for 1 and 4. So here while writing HCF means what I told you, this side number, factors, prime factors. Okay, so HCF is equal to 3 into 5. 3 multiplied by 5, that is 15. Okay, and what is LCM? These factors plus these factors. Correct. So we have to write both the factors. So LCM is equal to 3 into 5 into 1 into 4. That is equal to 3 5s are 15, 15 1s are 15, 15 4s are 60. Correct. Now our property. This we have found the HCF, we found the LCM. Now we have to verify for the property. Correct. So product of two numbers we have to find out, that is HCF and LCM is equal to how much and product is how much. Correct. So we write down here HCF into LCM is equal to product of two numbers or given numbers. Correct. So you will write HCF is how much? 15, LCM is 60, and the given numbers are also same, that is 15 and 60. 15 into 60. So 15 6 are 90. So it will come 900, and this is also 900. So the given property is true. We have to verify. So we have verified that both the sides are same. That means this property is been verified, or this property is correct. Okay. Now let's go for fourth sum, that is 18 and 63. Two numbers they have given, that is 18 and 63. So we'll draw the lines, horizontal vertical lines for this one, and we'll start dividing these numbers. We have to find out any number which divide both. Okay, you can divide 18 by 2, but you cannot divide 63 by 2. So I can't take 2 on this place. I have to take 3 here. So 18 divided by 3. So 3 6 are 18 here. 3 2s are 6, 3 1s are 3. Correct. Again repeat with 3 2s are 6 and 3 7s are 21. So here we got the prime numbers. Further we cannot find out the factors. So we have to stop at this step. HCF, that is 3 into 3, that is 9, and LCM. What is LCM? All factors. These 3, 2, 7. So 3 into 3 into 2 into 7. So number comes 3 3s are 9, 9 2s are 18, and 18 7s are 126. So we got the LCM 126. Now next step is what? To check the property. This we have to follow. So we'll write down HCF into LCM is equal to product of numbers. So I will write HCF is 9, LCM is 126, and 18 numbers which are 18 into 63. Correct. So we will find out, or when we do this work in the rough, we can find out that HCF into LCM will be 1136. 4, and this number is also 1134. That means both the sides are verified, or both the sides are same. So what I am doing here, see children, I am drawing this equal sign and writing this tick mark. Means what is the meaning of this? That this gives you the meaning that 900 is equal to 900, that is proved. This tick mark is symbol of proof that we have verified. Okay, so compulsorily you put this tick, or else you have to write it in a statement form that both the sides are verified. So better shortcut, you just put the tick between these two numbers. So this was fourth sum from practice set 13. Question number 2. Now let's move for fifth sum. Now in fifth sum, two numbers they are given is 78 and 104. Okay, so we have to find out one common number by which you can divide both 78 and 104. As you can see in the unit place, it's 8, it's 4. So we can divide these two numbers by 2. It will be 2 3s are 6, 2 9s are 18. And this is 2 5s are 10 and 2 2s are 4. Correct. Now one more number we have to find out by which we have to divide both 39 as well as 52. Now 39 and 52 both comes in the table of 13. So I will write here 13 3s are 39, 13 4s are 52. Now we don't have some common numbers by which you can divide 3 and 4, so we have to stop. So what we'll write here, what is HCF then? HCF is equal to 2 into 13. So that is equal to 26. Correct? And what is LCM? LCM is equal to 2 into 13 into 3 into 4. So that number 26 into 3 will be 78, and 78 multiplied by 4, 312. Now children, I am doing this calculation orally. If you can't do it, you have to do it in a rough work. Okay. Now we have to verify for the property, that is HCF, product of HCF and LCM should be equal to product of numbers. So I will write that property. What is this? 26 into 312 is equal to 78 into 104. Now if we do the multiplication for 26 into 312, correct? So it will come 8112. I have already done it into the rough work. Okay, this I cannot do orally. I also have done a rough work. And 78 into 104 also will be 8112. So you can see both the sides are equal. So I will put here tick mark. That means HCF and LCM is multiplication, or its product is equal to product of two numbers. This property is verified. Okay, so here we are ending practice set 13.